All right, so review. Our equations can be written in three ways. We have our general form, right? And general is ax squared plus bx plus c. What's your y-intercept in that graph? Remember which one? The y-intercept, the c value. The c value is your y-intercept. And what does a tell you? If it's positive, it opens up, negative opens down. Then we have factored form. And factored form, that's a nice form, yes, it's very nice. It tells us, what does m and n stand for? The x-intercepts, right. And we can get our vertex by using the middle, right? Our vertex is going to be between our two x-intercepts. Standard form. Standard form is where we're given our vertex in our equation. So h comma k is the vertex. Here m and n was the x-intercept. So those are the three forms. So really, it all depends on what they give you for which equation we're going to make. Usually, we're always going to, when we're making our equation, use this one or this one. Because we're either going to know our x-intercepts or we're going to know our vertex. The other one, you have to always change it into that form. You can't just start off in that form. Okay, so we're always going to be making it in standard or factored form by finding the vertex or the x-intercepts and then solving for our a value, which we've done before. So here is the Golden Gate Bridge in San Francisco. You ever seen it? It's really cool. On Full House, maybe? Okay. It's one of the most internationally recognized bridges in the world. When it was built in 1937, it was the longest suspension bridge span in the world. The shape of the main suspension cable is a parabola that is more than 1 mile in length. That's pretty long. For a bridge. But nowadays, like, there's some big, long bridges. Okay, so there's ones that go, isn't there one that connects, like, Japan and, like, yeah, and it's the longest bridge. So anyways, moving on. In the diagram above, guys, okay, so in the diagram above, the road across the bridge is 245 feet above the water. So the bridge itself is 245 feet above the water level. So that means this distance here, right? This distance here to here is 46. I don't know why I said 5. No. The two towers are 746 feet above the water level. So from the top of the tower to the bottom, right, is 746 feet. So what does that mean about between the road and the top of the tower? Would be 500. So this would be 500. You subtract them. So from the top of the suspension to the bridge, it's 500 feet. And they tell us the two towers are 4,250 feet apart. That whole length across, 4,200 feet apart. The lowest point of the parabolic cable is 10 feet above the ground, or the road. So this part right there is 10 feet, that distance in between. Okay? So we can make an equation. We just have to put an axis somewhere, our y and x. And so suppose we put our plane so that here's maybe if you highlight the axis, it might help. Here's going to be our y-axis, and here's our x-axis. Okay? So let's put our points on here. Okay? So this point right here, where the cable connects with the first tower is 0, 0. Now remember, how far apart were the towers? 4,200. So the second point over here, what would that be? X is first, 4,200, comma, 0. Y is 0. Okay? Now, this is our 0. What was the distance between the top of the tower and the river? No, and the river. No, that was the top of the tower and the road. So this here would be negative 500, right? And this below would be negative 746? 746. No, it's 246 between the road and the water. Yeah, the road and the water. Okay. And they also gave us one other piece of information. What was that? 10 feet, the lowest point. So what would be 10 feet above then, right here? This is 500, negative 490. Good. Could we figure out our vertex? How could we do that? If you know one x-intercept is 0 and one is 4,200. Halfway. It should be right in the middle. What would that be? 20. So this would be, what's half of 4,200? 2,100, comma 4, negative 490. Because it was 10 feet above. Okay, so state the coordinates of the top of each tower and the vertex of the parabola. So we got that. It's labeled. Labeled. Yes. Okay, so it says the equation of the function representing the parabola can be written in factored form. That's factored form, right? Use the points in A to determine the value of A, M, and N, and show that the equation of the parabola is that. Okay, so let's sub in what we know. What is our M value and our N value? What are our x-intercepts? 0 and 4,200. So our equation would be y equals A. We don't know what A is yet. X minus 0 times x minus. No, it wouldn't matter which one's M or which one's N for 0 and 4,200. No, let's simplify this. So A, what's x times 0? 0. So AX times x minus 4,200. Now we need to find our A value. There's a few ways we can do that. The best way, like, remember, what's the one method we used in the past? Man. Remember, y-intercept equals A times M times N. What's the problem with that case, using that? We know our y-intercept is 0. We don't have A. M is, one of them 0, one's 4,200. Does that help us get A? Because there's a 0 there. No, so that's not going to work because in this case, our y-intercept is 0. So we need to use a different method to get our A value. Well, all we need to do is sub in a point, any point on our graph other than 0, 0, and other than our zeros. Well, we know our vertex, so we're going to sub in our vertex. What's our y value? Negative 490 should be equal to A times, what's our x? 2,100 times 2,100 minus 4,200. So we subbed in our vertex. The only reason why that method over here didn't work was because our y-intercept was the same as our x-intercept. So that doesn't work. A times x. Okay, so we get negative 4,900 equals A times 2,100 minus 4,200 is, it's going to be a big number, that's okay. And then times it by the 2,100. So it's 2,100 times 2,100. Negative, yeah, it's a negative. Because this, yeah, I'll show you. In your calculator, because 2,100 times 2,100 minus 4,200. Okay, so negative, that is 4,410,000 negative. That's how much money you wish you had in your back pocket. Negative? Yeah, not the negative. That means you owe. Go, just claim bankruptcy at that point. Okay, next step is, get A by itself. Divide both sides by that number. And we're going to reduce it in our calculator as a fraction. 4 zeros, yeah. 4. So in your calculator, two negatives will be a positive. So negative 490 divided by my answer, second, negative. And then just go math, enter, enter. Uh-oh, we have to reduce it ourselves. Darn. Okay, let's do this the easy way. Does 490 go into 4 million?
Yeah.
Let's see. Let's do that. 4,410,000 divided by 490 goes in 9,000 times. So this can actually reduce to 1 over 9,000. Okay, so we're almost there. I know, this one is not good. So we want to plug it in now. So our equation was y equals a times x minus 4,200. Our a value is now y equals 1 over 9,000 times, or x, don't forget the x, times x minus 4,200. And we want to make it look like this, so what are we going to do? It says make the equation look like this. These do not look the same yet. We divide? Well, we have this times that. Distribute it. Distribute it. Get rid of the brackets. There's no brackets in that one. So 1 over 9,000 x times x is 1 over 9,000 x squared minus 42 over 9,000. So 1 over 9,000 times, put this away, 7 over 15x. Yeah, so if you typed it. Okay, so if you want, did you type it in? Okay, so negative, it was 1 over 9,000 times negative 4,200, and then math, enter, enter to change it to a fraction. Negative 7 over 15. Okay? All right, so there's our equation. Turn over to the next page. The questions continue. State the suitable windows. So let's graph this on our graphing calculator and state our windows. So go to y equals and type in 1 over 9,000 x squared minus 7 over 15 x. Okay. 1 over 9,000 x squared and then minus 7 over 15 x. We are. Now we want to think about our windows. Don't just randomly like, oh, I'm just going to play around until I get it. We have a graph right here that can help us. Right? 7 over 15x. Yeah. Oh, sorry. I'll turn it up after. Okay, windows. So looking at this graph, we should be going from 0 to 4,200 because our x-intercept was 4,200. And, okay, if we do 1, if the scale is 1, then you have 4,200 ticks.
Let's do 100.
At least 100. That gives us 42 of them. Or even 200 maybe, because that'll give you 21 ticks. And there's usually 20 on yours. Okay, now y, what's our minimum value in our y here? Minimum value.
700.
Negative 746 to 0. Sure. Could you go a little above it if you wanted to? Like 5, 10? Okay. And scale. Right now we have 756 scale, little ticks. So maybe 50s, 20s? Okay. Doesn't. So there's, I'm going to do 50. No, because that's your scale. Okay? Looks ugly. Why? That's what our suspension bridge looks like. No, if, that you don't have an X in there then. Where's your X? Okay, now if you wanted to have this road in here, y equals negative 500. That's where the road is. And if you wanted to have the river as well, we could go y equals negative 746. There's the river, the road, and the, hey.
Look at that.
Okay, and you could go and make it even like, make it bold. You don't have an X after your 1 over 15.
I don't know.
There you go. Okay? Okay, next page. So what was our windows? Let's write them in. X was 0 to 4,200, scale of 200. Y was negative 746 to, we did 10 or 20. Or what did I do? 10, I think? I think I did 10. I don't know. And a scale of whatever your scale you put in. Okay? Determine the height of the parabolic cable above the road 900 feet from the left tower. Determine the height. Is that Y or X? The height. Well, if you're talking height, road, yeah. So there we're looking for the Y above the road, 900 feet from the left tower. So here's my left tower. Right? And we want 900 feet. So 900 feet, when our X value is 900 feet from the left tower. So there's a few ways you could do it. We can plug it in our equation or just trace 900, enter. So trace 900, enter. We're looking for the Y. The Y is unknown. Trace, then the 900 feet, enter. Or you could have plugged it in your equation. 1 over 9,000 times 900 squared minus, was it 7 over 15? Times 900. And that would also give you negative 330. So what does that mean? Is that the height above the road? It says determine the height of the pair above the road. So if this is, let's go back to our picture. Okay, if we know that, what did we get, 330? Negative 330? Negative 330. Okay, we want the height above the road. How far is the road from that part? So we do 500 minus the 330 to get the difference in distance. So 170. So 500 minus 330 equals 170 feet above the road. That's where your picture is really handy. Very, very handy. Okay. I agree. Okay, now it says determine the equation in standard form. In this form, you need to know your vertex and your A value. Do we know our vertex? Yeah, what is it? 2100 and negative 490. Do we know our A value? Jesse, do we know our A value? What is it? 1 over 9,000. So we can go ahead and put it in standard form. So y equals our A value, 1 over 9,000, bracket, x minus h. What's h? Remember, it's h comma k. So this is the one that goes to the x 2100 squared plus k. So we're going to write minus 490. And there's the equation again. One more and then we're done. Okay. The cross-section of a satellite dish is parabolic with measurements as shown. Okay, so notice where they put the, where's the x and y axis? 0, 0. So let's draw that in. So here's our x. Just draw a straight line. Here's our x, here's our y. There's your axis. And 0, 0 is our vertex. Okay, so a Cartesian plane, that's the x and y axis, is to be superimposed on the diagram with the origin at the vertex of the parabola. If the maximum depth of the dish is 8 centimeters, determine the width of the dish to the nearest tenth of a centimeter. Okay, so before we can do anything, we need the equation. Now, which type of equation should we make? Factored form or standard form? Standard. Why standard? We know the vertex. We know the vertex. We use the equation y equals a times x minus h squared plus k. What's the vertex? 0, 0. Vertex is 0, 0. So before you can answer any questions, you always need your equation first. So let's plug it in. Y equals a times x minus 0 squared plus 0, which actually equals y equals a times, what's x minus 0? X squared. So that, what do we still need to figure out? A. So we need to know at least one point on the curve so we can figure out A. Well, they give us a point. They give us this point. Right there. Right? An x comma y. What's x at that point? How far away are you from the 0? 14. 14 comma. This point here is your 14 away. That's your horizontal. And your vertical distance is 6. So we can plug that in to get our A value. Okay, so what's y? So we have a point, 14, and 6. Which one's the y? 6 equals A times x is 14 squared. What's 14 times 14?
139.
Type it in. 196. So 190, no, 1996? 1969, isn't it? 196? Yeah, 196. Okay, times A. Yeah. And then what do we do to both sides? Divide by 196. Can that reduce? 6 over 196. 6 divided by 196. Can it reduce? So quit. 3 over 98. There's our A value. 3 over 98 is A. So now do we have our equation? Yes. So y equals, our A value is 3 over 98 x squared. Now we can go and figure out, okay, what are they asking? Uh-oh. No, that's right. No, that's right. Okay, it says determine the width of the dish to the nearest centimeter. The width. So what, if we knew what point, could we figure out the width? Both of the endpoints. I knew this endpoint or this endpoint, we could figure its width. If I knew one of them, could you figure out the width? Yeah, because it'd be double. So at this point, do we know the x value? No, that's what we're looking for, because x is the width, or half the width, actually. Do we know how high that is? 8. They give us the y value of 8. Now, you can either solve this graphically or algebraically. It's up to us. Sure, let's do algebraically. So 8 is our y value. 8 is the y value. And we're looking for x. Okay, how do we get rid of the fraction? What would you multiply both sides by? 98. What's on the bottom? 98. So multiply both sides by 98. Okay, so we're on this side. We have 3x squared. 98 times 8, 784. Now what? Divide by 3, and then square root it. So divide by 3 is, okay, and then what? 61.3? 261.3, and then do what? Square root it. So what is the square root of that? Was this 3 over 98? Uh-oh. We made a mistake.
You made a mistake.
Guys, was this 0.4 and 16? How high is this above the x-axis? If this distance is 6, how much is this? That is 2. Wait, it's really easy. That was 2. So this is 2. Sorry. I just noticed that. 2. So this is 1 over 98. That's all. So this is just a 1 over 98 here. This is a 1 over 98 here. So we would just had here 784 equals x squared when we multiplied both sides by 98. Okay, so square root of 784. 28. There we go. Okay, so if that's, what's our width then? If this is 28, what's the whole width? How would you get the whole width? Times it by 2. 2 times the net 28, 56 is the width, and centimeters. Okay, your assignment is 1 to 4. 1 to 4, not 1 to 6. Okay? It is. Well, maybe I'll give you part of the class to do work, like the first 20 minutes. Okay, as long as you use this time right now, then I'll give you some time tomorrow. Okay? So numbers 1 to 4.